Hi friends, this is Mallikarjun Reddy. In this video, mainly made for mechanical concepts and with practical examples. See here, this engineering services exam I am taking for example engineering services exam 2022 paper. In this paper, first we will see one question. See, the question is in general, annealing is carried out to option A increase softness, increased stresses, C decreased ductility, D decreased toughness. This is actually this problem is linked with this concept. So before attempting this question, the person has to be very crystal clear about this concept. So, and also one more question also came from this topic. In which of the following microconstituents ferrite plus Fe3C phases are present? Like this, the questions has come. Two questions has come in engineering services from this topic. So, before going to solving these questions, let me explain this topic, and after that, we are able to answer the question easily. See, here the concept is heat treatment. This is the subject in material science. In material science, let me give some small introduction about material science. Why we need to study the material science? See, material science, if you want to design any object, any product, before going to manufacturing the product, we have to check the properties. How, for example, let me take a shaft. Here, in this shaft, by seeing the external thing, we cannot decide whether this product is useful for our manufacturing. So we have to check internally. So in this shaft, I have taken a small pot with electron microscope. I have seen, we can see this structure. In this structure, this is in this structure, these are three grains are there. If you observe closely, there are atoms in different orientations and having some grain boundaries. This is one grain, this is another grain, this is another grain, and also having three boundaries. That is called grain boundaries. So, in microscopic point of view, we have to check the properties. So in material science mainly deals with this microscopic point of view. See, in this material science, if you see here, these there are atoms are in different orientations. In these grain boundary atoms, if you take grain boundary atoms, the distance between these grain boundary atoms, that is bond length, is more. So because of this bond length is more, these interatomic forces are very less. Because of this interatomic forces are less, any foreign particle comes. For example, you take atmospheric oxygen. So because of this interatomic forces are less, this atmospheric oxygen will come and it will make corrosion. So to avoid this, what we have to do? We have to add some chromium. If you add chromium, it will go and it will settle and form a layer of chromium oxide, that is a protective layer, that improves the corrosion resistance. So like this, in material science, in microscopic point of view, we have to see. See, now come to our topic, heat treatment. What is heat treatment? Heat treatment is process for which we have to get the desired properties by heating and holding and cooling to get the required properties. Now we'll see this diagram. On x-axis we have seen time, on x-axis, y-axis we have taken temperature. See, we are heating and holding and cooling. The first process is annealing. In annealing, This is heat treatment process, and with this process we got some microstructure through annealing process, that is heating, and furnace cooling, that is in furnace means slow cooling, we will get coarse perlite. And after that I will explain how deeply I will explain about coarse perlite, fine perlite, and what are the microstructures. Next one is normalizing. This process we are heating and cooling in air, that is somewhat fast cooling. So we will get one microstructure that is called fine perlite. Next process is arc tempering, interrupted quenching. So we will get one microstructure bayonet. Next is tempering, quenching. In this quenching process is by using water, oil, brine we can use, and we'll get a very fast cooling. That form microstructure formation is martensite. And this martensite is very hard. So what we have to do is again we have to heat, and after quenching, then we will get a tempered martensite. So with this heat treatment process, we got some microstructures, and microstructure also we are going to see. The first one is coarse perlite. In coarse perlite, you see, because of annealing process, annealing means furnace cooling. So the temperature is high. So at high temperatures, what will happen? This carbon diffusion rate means carbon moving distance. Carbon is moving fastly, very fast. It is moving very fast because of high temperature. High temperature. So it is moving and jumping, and it will form a thick layers. Thick layers of alpha and Fe3C will get. So high temperature, this growth rate is increases. High diffusion. That means new grain formation is less. Why new grain formation is less? Because carbon is moving very fast, so it is very the growth grains for new grains formation is very less. That means if you see, observe this structure, grain boundary area is very less. So because of this grain boundaries areas are very less, the obstacles in path of dislocation is decreases. Because boundaries are very less, so obstacles are no obstacles for moving of dislocation. So the dislocation easily travel because of grain boundary area is less. So if it is easily travel, then we will get a very soft and ductile structure. Very soft and ductile. So in coarse perlite, we will get very soft and ductile. And if you see this, next we will see fine perlite. In fine perlite, because in fine perlite which process we are using? Normalizing process. In normalizing, it is air cooling. So that means the temperature is low. In furnace temperature is high. Here in air temperature is low. So because of low temperatures, the diffusion rate is decreases. So carbon moving distance is very less. So more grains will form, more grain boundary areas will form. So because of this grain boundary area is increasing, the obstacles in path of dislocation is increasing. This dislocation travels, it is not easily travel because grain boundary area is very high. So it is, the dislocation cannot travel easily. So what will get? Less ductile. If dislocation moving easily, that means that the ductile properties increases. But here dislocation, the obstacles are more, so dislocation moving is very tough. So we will get less ductile than the coarse perlite. So we will get in this fine perlite, we will get the structure is soft and less ductile than coarse perlite. So the next, if you see, these are heat treatment process and the microstructures formation, and what are the properties we got. So in this coarse perlite we got very soft and ductile, fine perlite soft and less. So whatever requirements we need, According to that, we have to follow. Whether we have to go annealing to get the very soft and ductile. If you want soft, less ductile than quartz perlite, we need to go normalizing. If you want another structure like binite, tempered martensite, we have to go these heat treatment processes. So in the like this heat treatment process will get microstructures. According to that, if you see this question, in general annealing is carried out. The option is increasing softness, increased stresses, C is decreased ductility, D is decreased toughness. So for this question, if you know this concept, we can easily answer the increases the softness. Annealing, in general annealing is carried out to increase the softness. And one more question in Engineering Services 2022 is, in which of the following microconstituents alpha ferrite and Fe3 phases are present? Which of the microstructures alpha and Fe3C present? If you know this concept, easily I can say quartz perlite and fine perlite. We can answer easily by knowing this concept. Thank you.